Morning, welcome to Redox Online Academy tutorial. Thanks for watching our video tutorial online. Please, if you have not subscribed to this YouTube tutorial, please do well to press the subscribe button and the notification button to see all of our educative videos online. Please remember to share this video with all of your friends, families and relatives that are doing well, GC, GC and MTGC. I wish them all round success in every of their academic endeavor. Thanks once again. God bless you. Now here is volumetric analysis, and basically this type of titration is redox titration, because as we are going to be doing the titration between acidified KMnO4 and acidified KMnO4 and one complex salt is a redox reaction, and we call it redox titration. If you watch the previous video sent, we will have talked about the neutralization, titration, the one that involved acid, base and salt. But here we have a redox titration, and the question goes: A containing 0.79 gram of KMnO4 per 250 centimeter cube of solution. Now A is containing 0.79 gram of KMnO4 per 250 centimeter cube of solution, and B is a solution of ammonium sulfate, iron sulfate hexahydrate, of unknown concentration. Now we are now told that 25 centimeter cube of portion of B were acidified. You can see 25 centimeter of portion of B, which is of the salt, were acidified and titrated against A. So you can see that B is titrated or acidified against A using KMnO4. A is a KMnO4 reagent. So the results are recorded in the table below. We have the product reading, first title, second title, and third title. But in this table we have incomplete table reading where we have spaces that we have to fill in. Now the first question says complete the table. Complete the table. That's the first question. So I the table. No, this practical has been carried out. As you can see, we are given the table of the table of values. But here they left some tables to be obtained by the writer, by the candidate. Now, how do you complete this table? Just bring out the table. That's number one question. Complete the table. Copy out the table out. We have number one, A Roman figure 1. Just draw the table out. Now to our voice, wasting much of our time. Draw the table out. We have the breath reading column, the first title, the second title, and the third title. So we have the breath reading. The breath reading, the unit is centimeter cube. The unit is centimeter cube. The breath reading, the first title, second title, and the third title. We have the final reading, the initial reading, and then the volume of A used. Volume of A used. You have the initial, the breath reading, the final, the initial, the volume of of A used. Now in the first column we have 24.80. Then we have 0.00. Now to get the volume of an acid used in the first title, just subtract this 0, just subtract 0 from 24.80. So we have 0.824. So we have we have 0.8 0.42 or 24. So you have just 4.80 on the first column. You have 34.50. Now there is a space here that we are to fill. So I are given 24.00 here. So to obtain this, just take away this from this, because the difference between this and this column will give us this. So difference between this column and this column will give us this. So difference between this and this will give us this. So subtract. So how do we subtract? 0 minus 0 we have 0, 5 minus 0 we have 5, 0.4 minus 4 we have 0, then 3 minus 2 we have 10. So it means that the value here, please note the value here is 10.what? 10.50. Now the last one here we have 6.55, then 24.10. 24.10. Now we have supply the answer that is here. Now here we know that you have to take this away from this to get this. So we are going to add this together. So we are having what? 5 plus 0 we have 5 from the back. 5 plus 1 we have what? 6 point. Now 6 plus 4 we have 10. We have to write 0, keep 1. So there's nothing here. 0 plus 2 plus the 1 you keep, making 3. So these are the 3 values that I'm using in the tables, and we have done that. So complete the table, which is we have done that already. So calculate the average volume of AUs. Now to calculate the average volume of AUs it means to calculate the average value of what AUs, that is the average titled value. Average titled, and now to calculate the average volume of acid use, that is to calculate the average volume of AUs. Remember we are dealing with what's redox or titration of A, volume of both AUs. Now how do you go about that? So is to solve the average volume of AUs, that to look for 2 concordant values. 2 concordant values, or concordant, but not necessarily it has to be 2. You have to look at the whether the values are concordant. Choose the value that are concordant and divide it by the number of concordant values. So look at this now. When you look at 24.80, 24.00, and 24.10, you can see that this 28 is an outlier. It is it's very far from the 2 is an outlier. So you see the difference between 24 and 24.10 is just 0.1, and the quantile value should be in the range of 0.1 to 0.15. So these are that's why I always choose the title value 2 and 3 to calculate our average value of AUs. So we have to now, that is the second title plus the second title plus the third titled divided by 2. So we have the volume of AUs should be 24.00 plus 24.10 divided by 2. We have, when we add them together, we have 48.10 divided by 2. So we have volume of AUs is now 24.05 centimeter cube. Now from here now since we are cutting the volume of AUs, now what are the next things we have to do? Now the equation of the reaction is NO minus plus 5Fe2 plus AH plus to give what N2 plus 5Fe3 plus, and so on and so forth. If you can look at it very well, this KMNO4, which has what this MNO4, which has what the oxidation number of plus 7 here, plus 7, but it has become plus 2 here. That is means it undergoes what is a reduction reaction. So this is a reduction reaction, because there's a decrease reduction, and this and a species that undergo reduction reaction is an oxidizing agent. So that's why we said this is a redox titration, and this one has undergo oxidation. It has undergo oxidation. That's undergo oxidation. So and it's taught, and F is what F is called reducing what? Agent. But we are not going to that. That's why it is called, this titration itself is called what? Redox titration. Now, you are not have to calculate from your result. The information provided from the result and the information provided, calculate the concentration of A in mole per dm, the concentration of A in mole per dm. That was the next question to calculate. Calculate what the concentration of A in mole per what? In mole per dm. What's our A? These are A. Our A is KMNO4. Don't forget, our A is KMNO what? 4. Now, A, calculate what? Number 2 said 2B. 2B. We have what? Calculate in question 2, Roman figure what? Is question B, Roman figure 1. Question B, Roman figure 1 says, question B, Roman figure 1 says, question B, Roman figure 1 says, calculate the concentration of A in mole per dm. So concentration of A in mole per dm cube. In mole per dm, concentration of A in mole per dm cube. So how do we go about that? So look at the parameter given to us in A. A is what? It consists of what? Is 0.9 gram of KMNO4 per 250 centimeter cube. Now, 250 centimeter cube. Now we are asked to calculate concentration of A in mole per dm, which means we are looking for CA. That is molar concentration of A. Molar of A. That is molar concentration of A. Now, how do we calculate what? The molar conc of A? We have to use what? The molar conc of, to calculate the molar conc of A, you need to use what? The formula, which is molar conc of A will be equal to what? Mass conc of A all over molar what? Molar mass of A. So now, and how do we go about that now? We know that our mass conc can be obtained from what is given in the question, which is 0.79 gram of KMNO4 per 250 centimeter cube and 250 centimeter cube. Now let's quickly do that here. Just do it here so that let's quickly do it there so that we can substitute that. So let's calculate the mass conc of A. Mass conc of A now, the mass of A, which is KMNO4, all over what? Which is KMNO4, all over volume of solution. Volume of solution. The mass of what has been given, which is 0.79. 0.79. But the volume has to be taken to what? To volume is equal to 250 centimeter cube divided by 1000, which is equal to what? 0.25 dm what? Cube, and the mass M 0.79 gram. So we have what? Mass conc of A equal to what? M all over V, which is 0.79 all over what? 0.25. So we have mass conc to be 3.16 gram per what? dm cube. Gram per dm, 3.16 gram per dm cube. Now, so that's that about that. But now, successfully calculate this now. Successfully calculate what the mass conc. But what about the molar what? The molar mass of what? of A, molar mass of what? The molar mass of A. So also make sure that you arrange this thing very well. Mass con is calculated. And let's calculate the molar mass. So I can use what? I'm just trying to print out, calculate the molar mass. Let's calculate the molar mass A. So that we can use this place for our molar con. But do this thing systematically. So this is mass con. Then we have to calculate the molar mass. The molar mass of A, which is Kmn is equal to 39, because K is what? The relative atomic mass of K is 39 plus what? That of M is what? 55 plus that of O. So please M N O for that of O is what? That's oxygen. That is 16 multiplied by 4. 4 into bracket 16. So what do we have? We have what? 39 plus 55 plus 64. So the answer here, 39 plus 55 plus 64 equals 158 gram per mole. So it is like the molar mass. Please note the molar mass of KNNO4 is equal to 158 gram per mole. So now coming back to this now, your molar concentration of A, which is the Ca, is equal to now 3.16. That is mass con that gets all over your molar mass 158, which is equal to what? It is equal to 0.02 mole per dm cube. So the concentration of A in mole per dm cube is equal to is what? Is 0.02 mole per dm cube. Please note that that's the question. That's the first word. That's the how we get what. That's the first question under B. Number one of B. And let's proceed to number figure 2 of B. Number 2 of B. Now let me do it to clean this. That's to math much. Now, to calculate now B, remember 2. It said our concentration of B in mole per dm cube. Concentration of B in mole per dm cube, meaning that I have to calculate CB, molar concourse of B. Now you can easily use what? The formula Ca Va all over Cb Vb Na all over Nb. So can easily use us using what? Ca Va over Cb Vb equal to Na over Nb. Now what are the values that we're looking for? We have what the value we are given to. We are given what the value that we have at hand. The values that we have at hand are 0.02 mole per dm cube, the one that we just obtained now. That is the molar concourse of A used. So we have the Na. Let me just say the Va. They have it to be 24.05 centimeter cube. We have the Vb, which is 25 centimeter cube. We are told that 25 centimeter cube of what? Of B was what? was titrated against what? Acidified KMnO what? KMnO4. So Phoebe is 25 centimeter cube. We have what? CB is what we are looking for. CB is what we are looking for. Now, the Na, now, look at this. The Na here, this is A. This is what? This is A, this is B. So definitely the mole that is here is Na. This one is what? N what? NB. So Na is 1. Is 1. Na, because N here is 1, we have one molecule of what? MnO4. So we have what? One molecule of 1. So we have Na is 1. Na is 1. Then NB. You can see we have 5 ion here. We have 5. 5 NB is 5. So now substituting this parameter to get your B, now we have what? CB. We have 0.02 multiplied by volume balancing 24.05 all over by CB times VB, that's 25, equal to what's the NA? NA is 1, while NB is what? 5. So by cross multiplying, we have what? CB multiplied by 25 times 1, which is organization. So 0 equal to 0.02 times 24.05 times what? 5. Now divide both sides by 25. So this one automatically cancel what? This. So we have CB to be equal to 0.0926. So I only have that as your final answer, 0.0926. So that's the value for our CB. CB, that's the value for our CB. Now let's move to the next question. So CB 0.00926. Now CB is equal to 0.02 times 24.05 times 5 over 25. CB is equal to 0.0926. So let's question B. Roman figure 3 says that concentration of SO4 2 minus a mole per dm³ of B. Now question B. Roman figure 3. Concentration of SO4 2 minus a mole per dm³. A mole per dm³ of B. Now we have to recall what is B. What is B? We have to recall what is B. B, don't forget, B is said to contain ammonium sulfate, SO4 dot iron what? Sulfate, hexahydrate, that's 6 water. Now say how much, what's the concentration of SO4 2 minus? So talking about sulfate ion here. What's the concentration of what? SO4 2 minus in mole per dm³ of what? Of B. Now how do you get that? For side the equation out. N4, that is ammonium sulfate dot iron sulfate hexahydrate. Hexahydrate means 6 water. So to give you what? Like look at this, if you combine what, if you break this one down, when this thing dissociates in water, what do we have? We have 2 sulfate ion, 1 sulfate ion, 2 sulfate ion, we have 2 sulfate ion, plus we have what? Fe2 plus 2 ammonium what? Is how many ammonium ion you have? There's 2 ammonium ion. And see 2 ammonium ion here. So when this dissociates in water, when it breaks down in water, we have what? We have 2 sulfate ion, Fe2 plus, and 2 ammonium ion. So now we can see this water as what is one that this water, because this has already dissociated in water. So we are not considering the water. So these are the ions that are what in operation. when they dissolve in water, that the ions that we see 2 molecules of SO4 2 minus, Fe2 plus, and 2 ammonium ion. Now look at this. These are 1 mole of what? Look at this one. It means 1 mole of B produce 2 mole of SO4 2 minus. 2 moles of SO4 2 minus. So if 1 mole of B produce what? 2 mole of what? Of what? SO4 2 minus. Definitely the concentration which you just calculate 0.0926 mole per dm cube of B will produce the concentration of what? We'll just multiply this one. It will produce twice the concentration of what? Of B. So now what are we going to do now? We have produce what? We have twice the concentration of SO4 in what? Of B. Now we have what? We have 2 times, now multiply 2 times 0.0926 mole per what? dm cube. Mole per dm cube. So this one, if 1 mole of B we have to give this, then give 2 moles of what? SO4 2 minus 0.0926 mole per dm cube of what? To give this one we produce it. So we have what? 2 times this, we have 0.1924 mole per dm cube. Approximately equivalent to 0.192. So that's that mole per dm cube of SO4 2 minus. Now with that, we can also proceed. They said the last one said, okay, the mass of SO4 2 ion in 25 centimeter cube. The mass of what? SO4 2 ion in 25 centimeter cube. Now I can go with 4 mass. That's the mass go 4 mass of SO4 2 minus ions in 250 centimeter cube of B, 250 centimeter cube of B. And look at this, we are given the volume. So what we just need to calculate the concentration of what? Concentration of SO4 2 minus, don't forget, is given as what? 0.1924 mole per what? dm cube. So I've made that the concentration of any what? Of any substance will be given as what? Mole all over what? Over volume. Now we need to calculate the mole first. We have to calculate the mass because mole itself is mass over what? Molar mass. So we need to calculate mole first. Now to calculate mole, we need to transform this volume because we are given a specific volume 250 centimeter cube. Now, if I calculate the volume down to take the volume now, initially the volume is what? 250 centimeter cube. Now, so when we take it to what? dm cube, we have 0.25 dm cube. So, mole from here now, when you cross multiply, mole for here will be what? Mole. The mole of SO4 2 minus will be equal to C, the concentration that you just calculated of SO2 minus, multiplied by the what? The volume we just calculated, the volume of solution that we just changed into what? dm cube, which is what? 0.1924 multiplied by 0.25. So that's that. So when we multiply this one, what do we get? When we multiply it, what do we get? Whatever we get will be our what? Will be our moles. But let's take it, let's quickly press it. Let's quickly press it. 0.1924 multiplied by 0.25. That is 0.01. 0.0481. So when we multiply concentration of SO2 minus times V, which is equal to 0.1924 times 0.25, we are going to have 0.0481. So now, from this mole, this is mole. So we have moles. So this is mole, then we can now use what? The mole, the formula that's using mole equal to what? Mass all over what? Mass of SO for 2 minus over molar mass of what? Of SO for 2 minus. So now can just bring mass of SO for 2 minus now. We go to what? Mole times what? Molar mass of SO for 2 minus. Now, we need to calculate the molar mass of what? If we calculate the molar mass of SO4 into SO for 2 minus, let's see, this one is 32 plus 4 into bracket 16. What do we have? 32 plus 64, that is the red. So we have 96 gram per watt per mole. No, the relative atom mass is 92. That of oxygen is 16 times 4. That's how we get 64,000 plus 4 got 96. So we have mass of SO4 2 minus equal to mole that we get 0.0481 times what? Times 96, which is equal to times 96, which is equal to 0. You press that on calculator, what do we have? We have, press it on calculator, answer multiply by 96, what do we have? The answer is 4 point, answer is 4.16, so 0.614, 614 gram. So that's that about 4.6164,617. So we multiply. So mass of SO4 2 minus is equal to 0.0481 times 96, which is equal to 4.617 gram of SO2 minus. So that's the mass of SO4 2 minus. That's the mass of SO4 2 minus. So we have come to the end of the questions on the videos with titration. Please, if you have any questions, please remember to drop your question in the comment box or reach us with the line on the screen. Please do well to subscribe to this YouTube channel and share the video with others. Looking forward to see you in the next videos.